We are JEDI, Junk Elimination and Debris Interception. I'm Aman Priyanshu with
Surya.
Yes.
So we have a table of contents here where we'll initially describe a problem statement, our target market, our solution, our demo, and how does it work, some future ideas, and our team. So the looming space debris crisis. Space, as we know, is being filled with multiple satellites and etc., which are becoming incapacitated and broken down, which is leading to increasing space debris. Approximately 23,000 pieces of debris, larger than a softball, orbit the Earth. They sometimes travel at 17,500 miles per hour. This is a video from 2009. Which shows how drastically space debris has increased within the last decade. Now, coming to some of our key stakeholders. We are looking towards government space agencies, satellite operators, manufacturers, private space companies, environmental organizations, and a really key fun fact about this entire initiative is that the space debris is worth $1.2 trillion. Now, let's come to our live demonstration. So, this is JEDI, our platform which we have created. We have created a 3D simulation of the world where we are able to hover over different satellites. There are satellites, debris, as well as space stations. And we have created space stations as our key loci in our product. The key loci is from where we would leave out a robot cleaning service, and which would go about in an optimal path and try to clean up as much debris as it can. Now, let's begin by setting up our parameters. Let's say we have an upper time bound, an upper distance bound, and even the weight constraint on our cleaning robot. Let's submit these parameters to our optimal path model. So now for this optimal path, the distance traveled was 260 miles. About 1.4 million worth of debris was cleaned, 34 pieces of debris were collected, and 30,000 pounds of debris was aggregated by the end within a time period of 62 minutes. Now, this is the optimal path that was found by our optimal flight planning algorithm. Now, as you can see, these are on multiple altitude levels at different orbit plans, and it is optimal in the sense that we are optimizing for money, budgeting for time, as well as distance traveled, thus allowing us to reduce cost in space cleaning. Now, returning back to our presentation, so our key innovations were eco-friendliness. Our solution minimizes space debris and reduces environmental impact of space activities. It's cost-effective by utilizing our optimal flight path for maximum debris collection. We offer a cost-effective solution. It is scalable, that is, our solution can be adapted to address different types and different sizes of space debris. Finally, looking towards expanding our horizons, we are looking towards recycling precious metals and saving money, as well as opening up a marketplace, bringing memorabilia from space and auctioning it back at Earth. Now meeting the team from right, Aman Priyanshu, Yash Maurya, and Surya Ganesh. Thank you and have a nice day.